Okay, in Algebra 2, Module 2, we're going to be talking about systems of equations. And particularly in Section 1, we're going to talk about solving systems of equations by graphing. So first off, just to define what a system of equation is, if you aren't familiar with this, a system of equation is a set of equations working together. In this section, we're going to be talking about two linear equations. But a system in general is a set of equations working together. A solution to a system of equations just means the values that satisfy the equations in the given system. So it's going to look like an ordered pair in this case. So I'll put in parentheses an ordered pair, or an x and a y. So let's look at the first example. The question says, which of the following ordered pairs are solutions to the following systems of equations? So we have three ordered pairs, and we have to determine if they are a solution to this system given x plus y equals 1, 2x minus y equals 11. To check this, let's try 2, 3 first. I'm going to plug in 2 as my x value, 3 as my y value, and see if these work. Are these both true? Well, let's check. Does 2 plus 3 equal 1? No, so it automatically fails this system of equation. But we can check the next one anyways. 2 times 2 is 4. 4 minus 3 is not 11, so it fails. We can say 2, 3 is not a solution to this system. So let's try to check for 3. 4 is my x, negative 3 is my y. Checking for negative 3, does 4 plus negative 3 give me 1? And then does 2 times 4 minus negative 3 give me 11? Well, 4 plus negative 3 is like 4 minus 3 does equal 1. So I'm just going to put yes there. And 2 times 4 is 8. Subtracting a negative 3 would be like adding 3 to 8. That does give me 11. So I'll make a statement that 4 negative 3 is a solution. Let's go ahead and check this last one. 1, 1. Checking the last set, 1 is my x and 1 is my y. Let's see if that's true. Does 1 plus 1 equal 1? And we want to check, does 2 times 1 minus 1 equal 11? Well, 1 plus 1 equals 2 does not equal 1, so that automatically failed. This next one, 2 times 1 is 2, minus 1 is not 11. So we can say 1, 1 is not a solution, which makes sense because there should only be one solution to these, and that solution is 4, negative 3. So that was checking to see if our solutions work, but there are a few ways we can find a solution by just given a set of system of equations. And again, in this section, we're going to focus on the graphical side. So to graph a solution of systems of equations, essentially what that means is we want to graph each equation, and like I said, these equations will be linear, so they'll be in the form of lines, and find the intersection point. The point of intersection between those two lines will be the solution to the system. And I'm going to make a little note. To do this, we will use Desmos graphing calculator. If you have a TI calculator, feel free to use that as well, because you can use that on the ACT. But we'll be using a lot of Desmos graphing calculator from now on in Algebra 2. You'll either find Desmos at the bottom of a Chromebook. We have that pre-installed on our Chromebooks. Or if you don't, you can just go ahead and Google Desmos graphing calculator or desmos.com, /calculator will take you right there. So what I'm going to do is I will split screen this so we can see Desmo's off to the side. We can still see the notes. And we're going to look at solving the following systems of equations and then checking to make sure our answer is a solution. So the nice thing about Desmos is that we don't need to restructure these equations at all. So what I'm going to do is I'm going to take these two equations, x minus 2y equals 0, x plus y equals 6. Now I'm going to graph them. You can zoom out, you can move the graph around, whatever you need to do to see. It'll show you the exact intersection point. So our intersection point is 4, 2, or x equals 4, y equals 2. Now let's check to make sure that's a working solution. So I'm going to plug 4 in for x, 2 in for y, and just verify that these are true statements. 4 plus 2 equals 6. Well, 4 minus 2 times 2 is 4. Does give me 0. Yes. 4 plus 2 does give me 6. So 4, 2 is the solution. I'm going to go ahead and do the same process here for our next set of equations. Let me delete the previous ones and say the first one is y equals negative 1/2 x minus 4. Second, x plus 2y equals negative 10. So we notice these ones will never intersect. These are two parallel lines. So let's make a note. We have two parallel lines here. Since they never intersect, this means there is no solution to the system. With two parallel lines, I'm going to put this to represent that implies that there is no solution to the system. All right, our next set here, we want to graph, describe the solutions, and classify the system. So graph, describe, and classify. So far we have an instance where there can be one solution or there can be no solution. So that's what it would mean to classify. Let me go ahead and graph these first. These two are now graphed. We can see there is one solution because there's an intersection point. That solution is 2, negative 3. And let me make a note. There is one solution, and that solution is at 2, negative 3. Okay, let's do the next one. Again, another set of parallel lines. This means, whoops, see if I can get it over here. Restructure this a bit. No solutions because parallel lines. And then looking at our last one, there we go. Let me plug these in. 9x minus 6y equals negative 6. 6x minus 4y equals negative 4. And we notice that these are actually the same line. So if I hide one of these just by clicking on the green, or I hide it by clicking on the orange, these are the same exact line. I want to make a note. These are the same line. And there's a mathematical term we use for that. We call that coinciding. Call that coinciding. And what does that mean for our solutions? Well, that means that this line literally intersects at every point. So there are infinite solutions.